A very good afternoon, my dear children. After a little gap, your Lalitha ma'am is back to explain the next topic from the chapter of atomic structure, that is the dual nature of electron. Yes, it is a very important topic. Louis de Broglie's concept of dual nature of electron. Yes, I hope all of you are doing better and watching my videos. Request all of you, those who are watching my videos for the first time, kindly visit the channel and watch my videos and kindly subscribe to my channel. Okay, right. Today we are going to learn about what? Yes, dual nature of electron. Okay, particle and wave nature of electron. That is a topic for today. What is the topic? Particle and wave nature of electron. Particle and wave nature. Particle and wave nature of electron. This is our topic for today. Okay. So, you all know that electron is a charged particle, negatively charged particle. Okay, which is present inside the atom and which keeps revolving round the nucleus like planets revolve round the sun. Okay, and we also have learned the concept of Niels Bohr theory of orbits. Okay, electron keeps revolving round the nucleus in circular orbits. Okay, Bohr's atomic model we have learned. Okay, so there is another scientist named Louis de Broglie. Okay, Louis de Broglie. Okay, he told that electron not only possesses particle nature but it also possesses wave nature. Okay, this is in accordance with what? Yes, in the form of light. You all know that light particles, light exists in the form of particles as well as it is also having wave nature. Isn't it or not? Light particles. According to which theory? According to Newton's corpuscular theory. You might have learned this in physics, isn't it? Newton's corpuscular theory. Okay, according to Newton's corpuscular theory, okay, light is having what? Particle nature. Light has particle nature. You all know this. Okay, light is having what? Particle nature. You all know that photons means what? Particles of sunlight are called as what? Photons. You all know this, I hope. Photons. What are photons? Particles of light are called as what? Photons. Particles of sunlight are called as photons. So light travels in the form of particles. Okay, corpuscles means what? Light particles, or photons are particles of what? Sunlight. This was proposed by whom? Newton. So this theory was called as what? Newton's corpuscular theory. Later, Huygens, another scientist named Huygens. I am just randomly writing down all these things. I'll make you to write the notes also. Just while explaining, we'll be writing some things on the board, isn't it? Okay. Right. Huygens theory. According to which theory? Huygens. Another scientist named Huygens. Okay, now Huygens. He proposed wave theory for light. Light is having what? Wave nature. Okay, Huygens wave theory. In the same way, okay, Louis de Broglie proposed that even electron, which is revolving round the nucleus, is also possessing dual nature as that of light. Okay, this is in accordance with what? Wave mechanical motion of electron. Okay, wave mechanical motion. Electron is possessing wave nature as well as particle nature. This theory was proposed by whom? Louis de Broglie. Okay, that's why particle and wave nature of electron. Electron is possessing what? Dual nature. Okay, so how he formulated this theory and what points are being discussed by Louis de Broglie in this theory, we are going to learn in this video. Okay, so let us learn the topic. Louis de Broglie proposed the dual nature for electron. Okay, as how light is having dual nature, Louis de Broglie proposed that even electron is also having, not only electron, even subatomic particles like electrons, protons as well as neutrons, all of them are having what? Dual nature according to wave mechanical motion of charged particles. And even the smallest particles, atoms, are also possessing this dual nature according to Louis de Broglie. Okay, so how he formulated the theory and how this theory is in accordance with our Bohr's atomic model, everything we are going to learn in this video. Okay, this is a very interesting topic, a very easy topic as well as a small topic. So, your concentration is very much required. Okay, keep concentrating on the exact concepts, on what concept teacher is focusing. Okay, request all children to focus on the concepts and learn the concepts with complete interest and concentration as well. Okay, so Louis de Broglie. Okay, who is the scientist? Louis de Broglie proposed that electron is having what? Dual nature. Electron is having dual nature. What is dual nature? Dual means double role. Dual nature. Okay, that means what? It is having particle nature as well as wave nature. Okay, so if it is having wave nature, what will be the wavelength associated with the electron wave? He even gave an expression to find the wavelength of electron wave also. Okay, so we have to learn about the expression derived by whom? Louis de Broglie. Okay, for electron wave. Okay, so wave nature, particle nature as well as wave nature. We already know about the particle nature of electron. Until now, in the structure of atom, we have learned what? Electron is having particle nature. It is the smallest particle of atom present inside the atom, revolving round the nucleus like planets revolve round the sun. Okay, like that we have described the structure of atom. We have learnt. Okay, in that we have learnt electron to be a smallest particle of atom, isn't it? Now we are going to learn about wave nature of electron. Okay, so how electron is exhibiting wave nature. Okay, we have to learn about that, right? So Louis de Broglie derived an expression. So now we are going to learn about what? Expression for wavelength. Wavelength of electron wave. Expression for wavelength. He even derived the expression for wavelength of electron wave. Okay, expression for wavelength of electron wave. So what expression he has derived? Means for wavelength. Wavelength means what? Lambda. Okay, to find the expression for wavelength of electron wave. How to derive that expression? Let us learn about that. Okay, so you all have already learned about Max Planck's equation. What is Planck's equation? Recall, according to Planck's equation. According to Max Planck. Okay, we have what? E is equal to h nu. We have learnt this equation. Energy of wave is directly proportional to what? Frequency. What is nu here? Frequency. And h is called as what? Planck's constant. We all know about this. We have learnt this equation. Here energy of any electromagnetic radiation. E means what? Energy of any electromagnetic radiation. E is equal to energy and nu is frequency of that electromagnetic radiation. Okay, isn't it? We are learning about the concept of structure of atom only through what? Electromagnetic radiations. It is possible to learn about the subatomic particles like electrons, protons and neutrons. We are going to learn about that only with the help of what? Electromagnetic radiations. We have one video regarding that electromagnetic radiations also. You can watch my previous videos. Playlist is also there. If you are going to follow the playlist, it will be very beneficial for you, right? So nu is what? Frequency, and h is what? Planck's constant. You all know this. Max Planck proposed this theory, and this equation, you call it as what? Planck's equation. Okay, E is equal to energy, nu is frequency of electromagnetic wave, and h is what? Planck's constant. I think you can remember the values of h. Okay, h, what is the value of h? 6.625 into, yes, 6.625 into 10 to the power of minus 27 erg second, or h value can be 6.625 into 10 power minus 34 joules second. This is the value of h. Of course, we don't have anything to do with this h value right now. Okay, but you have to remember this value because we have to use this value while doing numericals based on de Broglie's wave equation. Okay, so E is equal to h nu. Recall this Max Planck's equation. This equation, we will consider it to be the first equation which we are going to use to derive the expression for de Broglie's wavelength. Okay, right? So E is equal to h nu is our first equation, right? Now, we also have to recall one more equation which is proposed by Einstein's mass-energy relationship. Did you remember? What is Einstein's mass-energy relationship? The energy of a photon can be calculated on the basis of what? Mass of that particular electromagnetic radiation. E is equal to what? mc square. Okay, did you remember? What is Einstein's mass-energy equivalence relation? Did you remember? See, write this point. The energy of a photon. The energy of a photon. Here, what is photon? Particle of light, or generally any charged particle or any subatomic particle. You can call it as what? Here, you can treat photon as a particle of light. Okay, the energy of a photon can be calculated on the basis of what? Can be calculated by Einstein's mass energy equivalence. Albert Einstein proposed one relation, Einstein's mass energy relationship. Mass energy relationship. What is that? Did you remember? What is this Einstein's mass energy relationship? E is equal to what? mc square. Here E is energy of the electromagnetic radiation. M is mass of that photon, and C is what? Yes, velocity of that particular electromagnetic radiation, or here the velocity of the particle of light, whatever it may be. C stands for what? Velocity. Okay, here E is energy, M is mass of the photon, and C is what? Velocity. Okay, E is energy, E is what? Energy, M is mass of that photon, and C is what? Velocity with which that photon is traveling. So this, if you consider to be the second equation. E is equal to h nu is your first equation. E is equal to mc square is your second equation. Okay, in both the cases, in LHS you have E. If you are going to equate RHS values, means what? Right hand side, whatever are there, if you are going to equate them, equating 1 and 2. Okay, equations 1 and 2, you are equating them. Equating 1 and 2. What you are going to get? Equating 1 and 2, we get h nu, we are equating it to mc square, because on RHS both sides we have energy E only. So we will equate only LHS. So h nu is equal to what? mc square. Okay, you all can remember that in place of nu, I am just rubbing this in place of nu, you can even write c by lambda. What is nu? Recall nu, formula for nu. Frequency is equal to what? C by lambda. In place of this nu, what I am writing? C by lambda is equal to what? mc square. Okay, please recall this. Since nu is equal to what? C by lambda. In place of nu, I wrote what? C by lambda. Okay, so h c by lambda is equal to what? mc square. Here c and this square, we can cancel them. So h by lambda is equal to mc. You want what? Only lambda. Bring this mc to this denominator and lambda that side. From this, what you can write? Lambda is equal to h by mc. You can write it as what? Lambda is equal to h by mc. In place of c, if you can able to keep v. What is c there? C means nothing but velocity. So in place of c, you can even keep v also. Sometimes v stands for velocity. Here c stands for what? C stands for velocity of electromagnetic radiation. Here electron is also possessing wave nature according to Louis D. Broglie. That's why in place of c, sometimes you can even keep v also. So if you keep v, lambda is equal to h by mv. Okay, so this wavelength is called as what? Wavelength of electron wave according to Louis D. Broglie. Okay, lambda is equal to h by mv. And this can also be written as what? Lambda is equal to h by p. P means what? M into v. Did you remember? M into v stands for what? Yes, momentum. M into v stands for momentum. Mass into velocity means what? Momentum. So momentum of the electron also you can find with the help of this de Broglie's wavelength. Here lambda is called as what? De Broglie's wavelength for the electron wave. And h is Planck's constant and p is momentum of the electron. P can be written even as what? M into v. Mass into velocity stands for what? Momentum. Okay. So lambda is equal to h by p. You can use this equation while doing numericals, or lambda is equal to h by mc. Okay. Or lambda is equal to h by mv. Anything can be used as what? De Broglie's wavelength. Okay. Right. So this is a very important equation. We can keep this as equation 3. By equating equations 1 and 2, we got this lambda is equal to h by mv. Okay, let us take that as third equation. Okay, now please note down everything and pause the video. Try to understand the concepts, okay, before you learn. And knowing the concept better will be the best way to understand and learn. Okay, that is the best way, right? So lambda is equal to h by p. P means what? Momentum. Okay, please remember that point. Now coming to kinetic energy. Okay, we got wavelength of electron wave. If you speak about the kinetic energy, Ke. Okay, so what is Ke? Let Ke be Ke of the particle of mass m is E. Okay, let the kinetic energy of the particle. Here what is the particle, dear children? The particle is electron. Okay, so let the kinetic energy of the particle, here the particle is what? Electron. Kinetic energy of the electron of mass m. Mass of the electron is taken as what? M. Of mass m is considered to be E. Okay, kinetic energy we are taking it as E. Okay, kinetic energy formula all of us know. What is the formula for kinetic energy instead of Ke? See dear children, instead of writing Ke, I am writing only E. Because I have taken kinetic energy as E. So E is equal to half mv square. This is kinetic energy formula. You all know that. Isn't it or not? What is the formula for kinetic energy? Ke is equal to half mv square. In place of Ke, I am taking it as only E. Okay now. So just cross multiply. 2E is equal to mv square. Okay. So if you are multiplying both sides by m, okay, multiply both sides by m. Multiply both sides by small m. What you will be getting? 2 into E into m is equal to, here also you are multiplying it with m. So m will become m square into v square. Okay, 2em is equal to what? M square into v square. Okay, I am just writing the same thing here again. Please, without any confusion, write and practice. Okay. So 2em, how much we got, dear children? 2em. Here E stands for kinetic energy, m stands for mass of electron. 2em, how much we got? Is equal to m square v square. Okay, if I want to write only mv, mv is equal to what? Square root of 2em. Isn't it or not? I have taken square root, applying square root on both sides. Then what we will be getting? mv is equal to root 2 into E into m. Here again you know that mv stands for what? Yes, momentum. M into v means what? Mass into velocity means momentum. Which means what? P is equal to root 2 into E into m. Now in place of this P, if you are going to keep root 2 into E into m, what you are going to get? Okay, let us take this as what? Fourth equation. Now substituting 4 in third equation. Just third equation is also available here only without rubbing. Okay, I didn't rub. Please check out. Substituting 4 in 3. What we will do? Substitute. Substituting 4 in 3. What we will be getting? Lambda is equal to h by p. In place of p, what I am going to write now? Root 2 into E into m. So, therefore, lambda is equals to h by, in place of p, what I can write now? Root 2 into E into m. This can also be treated as de Broglie's wavelength. Formula for what? De Broglie's wavelength. So, expression for de Broglie's wavelength can be written in this way also. Lambda is equal to h by root 2 into E into m. Okay, now root 2 em. H by root 2 em. So, this can be treated as what? Equation 5. So, this is the expression for what? De Broglie's wavelength. Okay. Until now, I was telling Louis de Broglie told that electron is having wave nature. So, he just telling and deriving the formula or expression for what? De Broglie's wavelength. Okay. So, how he explained? Okay. How the concept explained by Louis de Broglie is matching with the Bohr's atomic model. According to Niels Bohr, what he told? Electron is having particle nature and electron revolves around the nucleus in circular orbits. Okay. So, how this wave nature is in accordance with Bohr's atomic model. Okay. That we are going to learn now. Please understand the point carefully. How this Bohr's atomic model and Louis de Broglie's wave nature of electron are matching with each other. How they are, both are in accordance with each other. Okay. So, both of them are correct only. Okay. So, that point we are going to learn now. So, what heading we will keep now? Louis de Broglie's concept versus Niels Bohr's atomic model. Okay. Now, what I am going to tell you? De Broglie's concept versus, for de Broglie, D small letter only I am keeping. Please, because wherever we find this name, we find D to be in small letter only. Okay. De Broglie's wave concept versus, okay, versus, VS I am keeping. Bohr's atomic model. How these two theories are in agreement with each other. Okay, how these two different concepts, how they are matching with each other, how both are related to each other. We have to learn about that. That's a very important concept. Okay, so Bohr's atomic model. Bohr's atomic model. How these two are in agreement with each other. That we are going to learn now. Okay, so you all know that Bohr's atomic model you have to recall now. Okay, postulates of Bohr's atomic model. Okay, so in Bohr's atomic model you have learned one of the important postulates. What is that? One of the important postulates of Bohr's atomic model is what we call angular momentum of an electron is integral multiples of h by 2 pi. Recall fourth postulate of Bohr's atomic model. According to Niels Bohr, what he told? The angular momentum. Okay, according to Niels Bohr. According to Niels Bohr, the angular momentum of an electron. Please recall this postulate. That's why I'm writing again. See, the more you write and practice, the best you can remember. That's why every time when I am explaining also, I'll write the concepts on the board so that will be picturized in your mind. Okay, please understand the points carefully. Writing and practicing makes you to remember the concept for long time. Okay, so I request all of you to please make a note. Just listening, only to some extent you can remember it. But if you write and practice, okay, definitely it will be making an impression into your mind for long time, right? According to Niels Bohr, the angular momentum of an electron, is equal to what? Is equal to the integral multiples of h by 2 pi. You have learned this. Integral multiples of h by 2 pi. Okay, that means what? According to Niels Bohr, he told one postulate. What is that? MVR. Angular momentum is what? M into V into R. Okay, if it is a linear momentum, it will be only M into V. If a particle is traveling in the circular path, then you have to consider the radius of that circular path also. Okay, here R is the radius of the orbit in which the electron is revolving. So MVR is equal to what? NH by 2 pi. Okay, this was proposed by whom? Niels Bohr. But he did not give any kind of mathematical proof for this statement. He just told, okay, that MVR, angular momentum of an electron, is equal to the integral multiples of h by 2 pi. This point he told, but he did not give any kind of mathematical proof for this. Okay, now with the concept of dual nature of electron proposed by Louis de Broglie, we can prove this also. That's why de Broglie's concept and Bohr's atomic model will be in agreement with each other. That's why what they told is absolutely correct. Okay, so let us learn about that. So how Louis de Broglie accepted this and gave mathematical proof for this? Let us learn about that now. Okay, so how he has proposed that? Okay, so what he told? See here, according to de Broglie, electron is traveling in the form of what? Electron wave. Okay, so suppose this is the nucleus and this is Bohr's circular orbit. As proposed by Niels Bohr, electron is traveling in the circular path like this. Okay, now electron is traveling in the circular path. Okay, now dear children, right? Electron is traveling in the circular path like this, right? Now, what as proposed by Louis de Broglie, electron is traveling in the form of wave. Okay, a perfect standing wave. Okay, a perfect standing wave. Do you know what is a standing wave or a stationary wave? Okay, it's a standing wave. That means the number of the crests and troughs, okay, which are formed in equal distances, and all of them are in same phase. Okay, here suppose if two ends of a wave, this is one end of an electron wave. Okay, it is traveling around the nucleus in the form of wave. If one end of the electron wave is getting connected with the other end of the electron wave without any deviation, they are just getting connected. Okay, like how if you are going to understand this in the form of a stationary wave. What is a stationary wave? If two waves of equal frequencies and amplitudes, okay, superimpose with each other, okay, and travel in opposite directions with each other without any deviations, then, okay, they are said to be in what? Phase. Both the waves are in same phase. Okay, they are in phase. Okay, please understand the point carefully. This is the diagram when both the ends of the electron wave are getting connected to each other without any deviations. Okay, in phase. Okay, please understand the point carefully according to Louis D. Broglie. Okay, if two ends, please note this point if you want. If two ends of an electron wave meet to give regular, two ends of an electron wave, if two ends of an electron wave meet to give regular series of crests and troughs, meet to give what? To give regular series of crests and troughs. To give regular series of crests and troughs. Okay, now regular series of crests and troughs. The electron wave is said to be in phase. Then the electron wave is said to be in phase. The electron wave is said to be in phase. Okay, now the electron wave is said to be in phase. This is in phase. Both ends are meeting without any deviations. Okay, suppose if they are not meeting each other, okay, then they will be out of phase. If they are not giving regular series of crests and troughs, if they are not giving, okay, then they are said to be out of phase. Please understand the point carefully. Suppose if this is Bohr's circular orbit in which the electron is revolving, okay, if the regular series of crests and troughs are not there, okay, that means if both the ends are not meeting each other, they are out of phase. Please understand the point carefully. The regular series of crests and troughs are not formed within the phase. They are out of phase. Okay. This is the case where regular series of crests and troughs are not formed. Then it is said to be what? They are out of phase. In such case, the wavelength is not equal to the circumference of the wave. Please understand the point carefully. In this case, okay, in case 1, when the electron wave is in phase, okay, the circumference of the Bohr's orbit is equal to whole number multiple of the wavelength of the electron wave. Okay, in this case, the circumference, this is very important, the circumference of the circular orbit. Okay, now please understand the point carefully. The circumference of the circular orbit is equal to what? The whole number multiple of the wavelength of the electron wave is equal to what? The whole number multiple of is equal to what? Whole number multiple of the circumference of the circular orbit is equal to what? The whole number multiple of wavelength of electron wave. Whole number multiple of wavelength of electron wave. This is very important point, dear children. You have to understand this very carefully. Okay. In this case, if they are out of phase, this is, however, we are not considering this case. Here it will be not equal to. If they are, the series of crests and troughs are out of phase, then circumference is not equal to the wavelength of the electron wave. If they are giving frequent regular series of crests and troughs, if they are giving, then circumference of this circular orbit will be equal to what? The whole number multiple of wavelength of electron wave. How you are going to write this in the form of an equation? Please understand me carefully. Okay, circumference of this circular orbit. You all know the formula for circumference of the circle. What is the formula for circumference? 2 pi r. Yes, is equal to what? 2 pi r. Wavelength of the electron wave. So 2 pi r is equal to the whole number multiple of wavelength. Wavelength means lambda, you know that. Whole number multiple, that can be n value. That n can be any whole number. Please understand this point very carefully. If they are forming frequent regular series of crests and troughs, and if the electron wave is in phase, okay, is in phase with the circular orbit. When it is out of phase, we are not learning. When it is in phase, okay, then circumference 2 pi r will become equal to n lambda. If it is out of phase, 2 pi r is not equal to n lambda. Please understand the point. This we are not considering. We are considering only this. Okay, we are considering only this one. So 2 pi r is equal to what? N lambda. Okay, so from this what you can write? In place of lambda, we are going to keep de Broglie's wavelength. Lambda means what here? De Broglie's wavelength. So here let us check. Lambda is equals to 2 pi r is equals to n lambda. Lambda is equal to what? 2 pi r by n. Okay, we have learnt already lambda formula. Formula for lambda, what we have learnt? This is which lambda? Electron wave. Lambda for electron wave. What is de Broglie's wavelength? Here lambda stands for what? De Broglie's wavelength. So in place of lambda I am keeping what? H by mv is equal to what? 2 pi r by n. Since lambda is equal to what? H by mv. Recall this formula. First formula I think we got. Right? So just cross multiply nh into 2 pi r into mv. Okay, so bring this 2 pi to the denominator on the other side. nh by 2 pi is equal to mvr. So we got of this relation. Okay, mvr is equal to what? nh by 2 pi. This was not given. Mathematical proof was not given by Niels Bohr. But then Louis de Broglie explained about the what we call wave nature of electron or dual nature of electron. Actually he told only about wave nature, as this theory is in accordance with Niels Bohr's atomic model. That's why we are proposing that electron is having what? Dual nature. Yes. Okay. So this equation we got with the help of Louis de Broglie's wavelength, isn't it? That means Louis de Broglie's concept and wave nature of particle nature of Niels Bohr's model both are in agreement with each other. Okay, mathematical proof was given by whom? Louis de Broglie. So mvr is equals to nh by 2 pi. Like this we got. Okay, so this is the concept of what? Dual nature of electron. Okay, I'm going to stop my video up to here. You have to pause the video. Okay, please note down all these concepts, what all being discussed here. Okay, Keep learning, happy learning. In the next coming video, we will be learning certain numericals based on the de Broglie's wave equation. Okay, until then, keep learning, happy learning. Your hard work is your superpower. Thanks for watching. Bye.